Okay, this video is a part 2 continuation of explanation regarding a binomial probability distribution. So let's continue. Let's say that we were given this information here. We were given that the number of trials was 13. Our probability of success is 0.5, which automatically means our probability of failure is also 0.5 because these two have to be complements of each other. And we're going to look up a bunch of phrases here, but let's say that we're looking up at least 8, the probability of at least 8 successes. In other words, they're asking us here to find the probability that x is greater than or equal to 8. That's what at least 8 means, okay? And x, again, represents, look at my part 1 video of this series here, x represents the number of successes, okay, successes. So this little notation here, as far as binomial probability distribution, means it's the probability of exactly 8 plus the probability of exactly 9 plus the probability of 10 plus the probability of 11 plus the probability of 12, and the last one is probability of 13. Now, how did I get all that? And why did I stop at 13? Again, the number of trials was 13, so I cannot exceed 13. There is no 14 or 15 or 16. I'm only going to try this out, whatever this distribution happens to be, only 13 times. So at least 8 includes 8, right? It includes 8, and it's all of these things summed up together. Now, if you're using a table in the back of your book, depending on where your book has this table, but the back of the book that I teach out of has this table in Appendix A. Let me just show you what it looks like right here. And I have over here, I have n is equal to 13. I know you can't read these numbers, but that's what it says. This second column is a bunch of x values, and it goes from 0 all the way up to 13. And I just look under its corresponding probability of success, right? Probability of success, which is one of these things. So if I was going to literally add up, if I was literally going to add up all of these numbers here, I need to go find this one, and this one, and this one, and this one over here in my table, and add all these things up. And I'm looking under my 0.5 probability of success, and here is the corresponding number for 8, 0.157, for 9, 0.087, for 10 it's 0.035, etc., etc., etc. So I'm just going to add up all of these numbers from here up to here. Right? I'm going to add up all these numbers in this column right here. Okay, well, let's go through this a little bit more, because what I really wanted to show you was not the table as much as what do these phrases mean. So that's what at least 8 means, right? At least 8 includes the number 8. That's pretty important. How about this one? What if you saw the probability of more than 8? You know, what if you saw something like that, more than 8? Well, what does that mean? That means the probability that x is greater than 8. But notice this time it doesn't include 8, right? This one over here is greater than or equal to 8, but this one does not include 8. So it would be these sums: probability of 9, probability of 10, probability of 11, probability of 12, all the way up to the probability of 13. Okay? So that's what, and you can see the only difference between these two here is this probability of 8 was not included, right? Because more than 8 does not include the value 8. Okay, there are other phrases here. How about this one? Slide this down so you can see it. How about this one? At most 8. At most 8. Right? What does that mean? Well, at most 8 also includes 8, right? It also includes 8, but it's now below 8. So at most 8 means x is less than or equal to 8. Right? So it's all the values now between 0 and 8 summed up together. Okay, that's a lot here. So at most 8 means a probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. You get the idea, all the way up to and including the probability of 8. Okay, so I could sum all of those values up, looking them up on my table. All right, how about this one? How about this last one here? How about the probability of fewer than 8? Fewer than 8. All right, fewer than 8. What does that mean? Well, this one is analogous to more than 8. It does not include 8. All right, it does not include 8, but fewer than means less than. So it's the probability of x less than 8. Right? Probability of x less than 8, which looks exactly like what I just did a second ago, except that it does not include this last value here, the probability of 8. It just goes from 0, 1, 2, etc., 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 all the way up to the probability of 7 and stops with that last one. So I could literally look all these things up on the table and I could add up all of those values, and that would give me the probability of fewer than 8. Hope that makes sense.